Yes, so what we say is needed for developing resistance in these mosquitoes and indeed other organisms is chronic low dose exposure. Well, first of all, it has to be a low dose because a high dose will kill the mosquito. So if a mosquito basically needs to survive long enough to pass on its genes, its characteristics that are making it more tolerant to pesticides. At least the farms we visited, the homestead is quite near the farms, and the farmers who are working in these farms, well, they keep these pesticidal compounds in their homes. So first of all, the proximity of the farm to the house means that what you're spraying in your farm ends up through pesticide drift in your homes. I would say it's not just the nearby farms. Recent research in Germany has shown that pesticide drift can reach up to 100 kilometers. So I think if you're in a farming village or several farming villages and where commercial farms also exist, those are being brought in also through pesticide drift or wind erosion, things like that. And then, like I mentioned, the farmers themselves are storing these compounds in their homes. So there's a chance of, spillage, contamination, leakage, and maybe damage to the bottle or improper keeping. Yeah, anything can go wrong. So what we found in Zambia is that the pesticide seems to be persisting longer in the house dust than in the soil. And this could be for a number of reasons. When the pesticide is applied onto the crop and lands on the soil and is brought into the house either through pesticide drift or on the bottom of the shoes of the people who work there, once it's inside the house, it's actually shielded from the sun. So photodegradation is one of the major methods that pesticides are broken down. The other method that pesticides are broken down is microbial degradation. So in the farms, there is quite a few feet, meters of soil where a lot of microbes live. And when these pesticide compounds reach these microbes in the soil, they are detoxified, they are digested, they are broken down. Of course, phytoremediation as well, in which plants do the same thing. They absorb the compounds and break them down. But this is not happening inside houses because they are shielded from the sunlight, so there's no photodegradation. There's not feet or meters worth of soil. There's only maybe a millimeter or so there's not that much microbes. And there's no plants. So this leaves very few options for these compounds to really degrade inside the houses.